Hello everyone. You might have memorized that binary search is of order log n, but gives you a random loop with an if statement inside and you're suddenly stuck. That's the problem with most DSA content. They teach you how to memorize complexities, but they never teach you how to derive them. By the end of this video, you will be able to look at any piece of code you never seen before, and find its complexity from scratch. No memorization required. So let's start. So now let's start with our examples. Here we have a code snippet written in C. In case you don't know C, you can check out my C series playlist. The link will be in the description. We are using C because C is one of the most easiest language to learn DSA in. So here we have for loop, where I is initialized to 0, I will be incrementing till it reaches n. And inside this for loop we have written a statement. This statement can be anything, any block of code. I have written an algorithm. That's why I can write anything here, because I don't have to run it. Now let's take an example here that n is 5. So what will happen? I will be initialized to 0. Then I will become 1 after incrementing 2. And then it will finally become 5. So we can check the number of times these statements are running inside the for loop. So now let's check the first one. So I is initialized to 0. How many times do you think this statement will happen? Because here I is only initialized, this happens only one time. Then let's check how many times I has been incremented. So here I is 0, so no incrementation. Here I becomes 1 because it is incremented. So we can say that this is 1, 2, 3, 4, 5. This is running for 5 times. And 5 is what? Rn. So you can say that this statement, this incrementation will run for n times. Then here is the condition, I less than n. So how many times this condition will check? Let's see. I is 0 firstly. So 0 is less than 5. Yes, correct. Count it. 5. 1 less than 5. Yes. 2 less than 5. Yes. Then it will check for all of these till n. So how many times this condition has been checked? I am saying this condition has been checked, not executed. So it becomes 6 because the condition is being checked 6 times. So you can write here that it is 5 plus 1, which is n plus 1. This condition will run for n plus 1 times. Here we can now say that how many times the for loop will run. For loop will run for n plus 1 times. We are only checking this one, how many times the condition will check. So the number of times the condition is checked depends on how many times the for loop will run. But here the statement, because we are only checking till I is less than n, which means we are only checking for 0, 1, 2, 3 and 4. This is 5 times. If we go to I equal to 5, condition will check it, but it will not be executed. So we can write here that statement will execute for n times. And then lastly, we can sum all this and write 2n plus 1. So this is nothing but a function. It's a function which is called fn equal to 2n plus 1. Now we have to find the time complexity of this. So how can we find the time complexity of this? Is we use a notation which is called big O, and inside this parenthesis we write the variable in the function. We write the variable with the highest degree in the function. So what it is? It's this one, n. N its degree is 1, which is the highest in this function. So in the brackets of notation we write that variable which is n, and that's it. We have our time complexity. Our time complexity is big O of n, or we can also say it order of n. So now let's see at our next example, which is a nested for loop. So in nested for loop, first for loop will decide how many times the inside statement will run, and the inner for loop will decide how many times this statement will run. So here we can say that this for loop will run for n plus 1 times, because we have to calculate how many times the condition will run. As we saw here, the condition runs n plus 1 times, and that's how our for loop runs n plus 1 times. So it runs n plus 1 times. Similarly, our inner for loop will also execute for n plus 1 times, but as it is inside the outer for loop, and the outer for loop will execute inner block of code for n times, we have to write here multiplied by n. For loop will run for n plus 1 times, and because it is inside another loop which executes its block of code for n times, we write here n and we multiply it. So how many times the statement will run? It will run for n into n times, because this for loop will make this statement run for n times, and this outer for loop will make all these statements run for n times. So you multiply them. Now let's add all this and write a function. So our function becomes 2n square plus 2n plus 1. So this is our function. Now let's calculate time complexity. It's big O of, in brackets we write the variable of the function which has the highest degree. Here this one has highest degree, which is 2. So we just write here order of n square. And always remember, whenever we are writing time complexity in the form of order of n or big O of n, we have to drop all other terms and the constant. That's how we calculate time complexity. So again, let's use this method. How many times will this outer for loop run? It's n plus 1 times. Then how many times this for loop will run? It's also n plus 1 times, but because it's a nested loop inside another loop, it will run for n times. So its total will run from n plus 1 into n times. How many times this will run? This will also run for n plus 1 times, but because it is inside another for loop which runs for n times, and it is also another for loop which runs for n times, so this will total run for this much time. And how many times our statement will run? Because it is inside 3 for loops and all these for loops will run for n times, we can say that this will run for n into n times. So if we sum all these, we can write our function as fn equal to 2n cube plus 2n square plus 2n plus 1, and with this function we can calculate our time complexity, which is order of n cube. Again, we wrote n cube because n cube is the variable with highest degree, that is 3, and by dropping all the other terms and the constant, we got our time complexity, which is order of n cube. So that was all for today. From next video we will discuss more algorithms and find their time complexity. Thank you.